Hello everyone, welcome to my channel. Now in the JEE NEET series for 2019, this is the second video from the chapter Electrostatics. Now in this video I am going to discuss the topic of electric field due to a uniform sphere, that is a solid sphere, as well as a uniform spherical charge sphere. Okay. Now in previous few years, if you go through the NEET papers or AIIMS papers or JEE main papers, questions have been asked based on electric field due to a charge distribution on a sphere, solid sphere or a hollow sphere. Okay. So first we will discuss the electric field due to a uniformly charged spherical shell, that is a hollow sphere. The charge is on the surface of the shell. Okay. Now suppose this is the shell of radius r. Okay. So charge is on the surface. Okay. Now outside the surface at distance r, which is greater than capital R. Suppose this is the point of observation. Okay. So at this particular point of observation, which is at a distance r, which is greater than capital R. So if you draw a Gaussian surface, and suppose Q is the total charge on this surface, then enclosing this Gaussian surface, the charge is Q. Okay. So if you apply Gauss theorem, it is E ds is equal to 1 by epsilon naught times the enclosed charge. Okay. And if you integrate this ds will be the area, surface area of this Gaussian surface. Now if it is of radius small r, the surface area of this Gaussian surface, which is spherical in shape, it will be 4 pi r square. So E times 4 pi r square is equal to Q by epsilon naught. So that gives E is equal to 1 by 4 pi epsilon naught Q by r square. So as you can see, this electric field intensity, it is inversely proportional to r square. So outside the sphere, the electric field intensity is inversely proportional to r square, where r is the distance from the center to the point of observation. Okay. Now by the same logic, if you are on the surface, okay, on the surface this r will be equal to r. On the surface, small r will be equal to capital R. So this small r will be replaced by capital R. So on the surface it will be E is equal to 1 by 4 pi epsilon naught Q by r square. Okay. Now, but if the point of observation is inside, suppose at this particular point, and suppose this distance is r less than capital R. Okay. Now at inside, if I draw a Gaussian surface, then inside this Gaussian surface there is no charge. So since there is no charge, electric field inside will also be 0. So E in, it will be 0. Okay. So this is the behavior of electric field intensity for a uniformly charged spherical shell. Okay. Now let's say the graphical representation of this electric field. So for this spherical shell, outside we have seen for r greater than r, electric field E out, it is 1 by 4 pi epsilon naught Q by r square, where Q is the charge on the surface of the spherical shell. Surface for r equal to r, it is E surface, it is 1 by 4 pi epsilon naught Q by capital R square, where r is the radius of the spherical shell. And inside for r less than r, E in, it is 0. So if we draw a graph, so suppose this is electric field and this is distance from center of the spherical shell, then this is the surface, so this is r equal to r. If you are inside the surface, that means r less than r. If you are outside the surface, that means it is r greater than r. So from center to just inside the surface, electric field intensity is 0. Electric field intensity on the surface, it is this quantity, and outside it is this quantity. Now remember, this small r is greater than capital R. So obviously this field will be less than this field. Okay. So that means, and outside, as you go out, this r will keep on increasing and electric field will keep on decreasing. So this is the shape of the graph. So inside there is no electric field. On the surface, electric field is maximum. So this ES is equal to E max. Okay, so for a spherical charged spherical shell, uniformly charged spherical shell, electric field intensity will be maximum on the surface, and outside the surface it will keep on decreasing because E out is inversely proportional to R square. Okay, so this is the behavior of electric field due to a spherical shell. Okay, now next we will see the behavior of electric field intensity due to uniformly charged non-conducting sphere. Okay, remember this, for a charge conducting solid sphere, the charge cannot reside inside the surface, okay, inside the volume. So charge will be on the surface. So that means the electric field intensity behavior for a hollow spherical shell and a solid conducting sphere, it will be same. The charge will be on the surface and the behavior of electric field intensity will be same. But if you have a uniformly charged non-conducting sphere, then the charge will be distributed throughout the volume. So this is the uniformly charged non-conducting sphere, and total charge Q, it is distributed throughout the volume. Let R be the radius and Q is the charge. Okay, now behavior of electric field intensity outside, again if you draw, if the point of observation is outside and if I draw a Gaussian surface, now inside the Gaussian surface again you will have charge Q. So the behavior of electric field intensity outside the solid sphere will be same as that for spherical shell. So outside you will get 1 by 4 pi epsilon naught capital Q by small r square, where small r is the distance from the center to the point of observation. Similarly on the surface you will have the same result as in the previous case. Okay, but when you come inside the surface, so if the point of observation is this, okay, now if I draw a Gaussian surface, okay, now this point of observation is at a distance r less than capital R. Suppose this is the point of observation. Okay, so now you have to consider this charge within this Gaussian sphere. Okay, now for the entire volume the charge is Q. Okay, so you have 4 in 4 by 3 pi r cube volume you have charge Q. So that means in unit volume you have charge Q by 4 by 3 pi r cube. So in this volume of radius smaller, the charge will be Q by 4 by 3 pi r cube into 4 by 3 pi small r cube. So this 4 by 3 pi gets cancelled. So that means the charge on this volume, it will be Q r cube by r cube. Okay, so this is the charge on this volume, okay, within this Gaussian sphere. Okay, so now since we know what is the charge, so electric field intensity, it will be E times this area 4 pi r square is equal to 1 by epsilon naught times this charge. Okay, so this charge is Q r cube by r cube. Okay, so this gives E is equal to, this 1 r gets cancelled, so Q r by 4 pi epsilon naught r cube. Okay, so this gives E is directly proportional to R. And what happens if you are at the center of the sphere? If you are at the center, point of observation of electric field is at the center of the sphere. Now at the center, this R will be equal to 0 and electric field intensity will be 0. And as you move out from the center, okay, towards the surface, E is directly proportional to R. Okay, so the electric field intensity is 0 at the center, and as you move towards the surface, the electric field intensity will be keep on increasing linearly. On the surface it will be maximum, and outside the surface it is inversely proportional to R square. So outside the surface the electric field intensity will decrease. Okay, so let's see the graphical behavior of the electric field intensity. So this is the expression for electric field for a solid uniformly charged sphere. Outside this is the E out is inversely proportional to R square. Surface electric field intensity is maximum. Inside E is 1 by 4 pi epsilon naught Q r by r cube. So electric field intensity is directly proportional to R. Okay, so this is the solid sphere. So this is the surface. So in this direction, this is electric field, this is R, distance from the center. So if you are on the surface, this is R equal to R. If you are inside the surface, R less than R. If you are outside the surface, R greater than R. Okay. Now center electric field intensity is 0. Inside it is directly proportional to R. So you will get a straight line till the surface. Okay. This is R equal to R. So you are on the surface. Electric field intensity is maximum. Outside inverse E is inversely proportional to R square. So the electric field intensity will decrease. So this is E inversely proportional to R square outside, and this is E directly proportional to R. This is inside, and at R equal to R, electric field intensity is maximum. So this is ES is equal to E max. So again, the electric field intensity is maximum on the surface. Okay, so these are the two important topics with regard to the electric field due to one due to spherical shell and one due to solid non-conducting sphere. Okay, and as I told you, for a conducting solid sphere, the charge will be again on the surface, so the electric field variation will be same as that for a hollow sphere or spherical shell. So hope these concepts are clear to you, and these concepts will be, I hope these concepts will be beneficial for your forthcoming NEET and JEE main examination. So my best wishes for your preparation and scoring well in the forthcoming examination. Good luck.